This is our last section for this unit on quadratic equations. We're going to take a look at the quadratic formula. You can solve quadratic equations graphically. Okay, we did that in 4.1. Okay, and the problem with that, if you're not using your graphing calculator, is you may not get exact roots. Okay, we solved quadratic equations by factoring. And the problem with factoring, of course, is you may not be able to factor. And we have, well, I've shown you how to determine the roots of a quadratic equation by using the square root method, and I'll just remind you what that is. Okay, so you would use that when b equals 0. So an example of that would be something like x squared, oops, I should put minus 25. Minus 25 equals 0, and you solve for x squared, okay, and then solve for x. And you get that x is plus or minus 5. And then, of course, by completing the square, which we did in 4.3, and completing the square works all the time. The problem with that is there are a lot of steps. Okay, so we did factoring in 4.2, and we did completing the square in 4.3. Now, there is a way to solve a quadratic equation that always works, same as completing the square, but some of you will like this better, and it's by using the quadratic formula. And so here is the quadratic formula: x equals negative b plus or minus the square root of b squared minus 4ac over 2a. And you will get this on a formula sheet, so I still would recommend that you memorize it, but you don't have to. So what we're going to do now is we're going to see where it comes from. Where does this formula come from? Okay, and it's quite involved. All right, so pay attention. And we're going to use completing the square to derive this formula. Okay, so by completing the square, you can develop a formula that allows you to solve any quadratic equation in standard form. Start with the general quadratic equation in standard form, ax squared plus bx plus c equals 0, and apply the steps to complete the square. Okay, so let's start. A squared plus, ax squared plus bx plus c equals 0. Okay, so first off, you want to group your first two terms, and you want to factor the a out. So when you do that, you will get a, and then x squared plus b over a x, and then we're going to complete the square after this. So I'm going to go plus space, minus space, and then plus c equals 0. Okay, so how do we get b over a? Well, remember, if you want to factor the a out, you divide each of these terms by a. So you're going to go ax squared divided by a is x squared. You're going to go bx divided by a, which is b over ax. Okay, so next we're going to complete the square. We want to take half of b over a, and we want to square it. Okay, so I'm going to do that over here. So half of b over a, which gives me b over 2a, and then I want to square that. So that means I square my b, and I square my 2a, which gives me 4a squared. Okay, so I'm going to add that. So b squared over 4a squared, and then minus it, b squared over 4a squared. Okay, so the next thing I'm going to do, I am going to distribute the a over the b squared over the negative b squared over 4a squared, and I'm going to pull it out of the bracket and combine it with the c over on this side. Okay, and then at the same time I am going to factor my perfect square trinomial. Okay, so a bracket, I'm going to factor this first, so I'm square root of x squared is x, keep the sign plus, and square root b squared over 4a squared, you should get b over 2a, and put a square on the outside. Then I'm going to go a times b squared over 4a squared and combine it with the c, so plus c, and then minus, I'm going to multiply the b squared by a, so I get b squared over 4a squared. And if you're not sure why that is, if I go a times b squared over 4a squared, I can put a over 1, right, because I'm multiplying fractions, and I go a times b squared and 1 times 4a squared, and so that gives me ab squared over 4a squared equals 0. Okay, so next I'm just going to move my c to the other side of the equation, as well as my negative ab squared over 4a squared. Okay, so I'm just rearranging some terms here, so that's not hard. And so I'm going to go, how do I want to organize this? I'm going to go minus c, and then plus ab squared over 4a squared. Okay, so now what I want to do is I want to take what's on the right hand side and I want to write it over one denominator. Okay, so I'll show that to you over here. So minus c plus ab squared over 4a squared. Now, because I want to write that over one denominator, what I want to do is make sure that my c has a denominator of 4a squared. Okay, and in order to give it a denominator of 4a squared, I also have to times my negative c by 4a squared. Okay, because I don't want to change the value of negative c, so if I times it by 4a squared over 4a squared, which is equal to 1, I still have negative c. It's just written in a different form. And now I can write this so that I times my 4a squared times my negative c, so I'm going to get negative 4a squared c, and then plus ab squared, which I can now write over the same denominator of 4a squared. Okay, all right, so I'm going to have to move this over a little. All right, so the left I haven't changed anything yet, but on the right now I have negative 4a squared c plus ab squared all over 4a squared. Okay, now what I want to do is I want to divide both sides of my equation by a, because I want to get rid of it on the left, and I can show division, and I'm just going to do this over on the side. So I can go, I'm going to just take a look at what's on the right here. So 4a squared c plus ab squared over 4a squared. So I want to divide that by a, because I'm going to divide both sides by a. Why don't I do that in blue? Okay, now when you take a fraction and divide by another term, okay, because our numerator is a fraction, we definitely have a numerator and a denominator in our overall numerator. Why don't I just write this like this? Okay, so really when I take a fraction and divide by another term, it really means to multiply the reciprocal. So I can just times this by 1 over a. Okay, so now on the left I have x plus b over 2a squared equals, and then on the right I'm just going to multiply my denominator here by a, so I have now 4a squared c plus ab squared over 4a cubed. Okay, so now, if you notice in your numerator here, you have a GCF, which is a. Okay, so leave the left the way it is. I'm going to factor an a out of the numerator, and that's going to leave me with negative 4ac plus b squared over 4a cubed. Okay. So now what I want to do is I want to reduce this a with one of the a's in the numerator. Okay, so leave the left as is. Reduce my a, so that's going to leave me with negative 4ac plus b squared over 4a squared. Okay. Now what we're going to do, now we can finally square root both sides. So I'm going to square root this side and I'm going to square root this side, and don't forget to put plus and minus in front of that bracket. So remember, a square root undoes a square, so on the left I have x plus b over 2a, and on the right I have plus and minus, and I can't do anything with the numerator, so I'm going to leave that in a square root, and I'm going to rearrange my terms so that I have my positive term first and then my negative term second. But notice that I can take the square root of 4a squared, because the square root of 4a squared is 2a. Alright, so hopefully this is looking less freaky now. Okay, so now I can isolate for x. I'm going to move this over here, and I'm going to get x equals, that becomes negative b over 2a, which should sound familiar to you right now because that should remind you of vertex formula. Plus or minus b squared minus 4ac over 2a. And because both of my terms on the right share the same denominator, I can just write them. I can just write my numerators over one denominator. So x equals negative b plus and minus the square root of b squared minus 4ac all over 2a. And here is your quadratic formula. Okay, all that work for one little formula. Well, actually, it's not a little formula. Some of you are going to use it a lot. Okay, so what does it mean? Okay, what it allows us to do is to solve for x. What that means is our roots. The other thing you should notice on this is, like I said earlier, the vertex formula is in here. So you've got negative b over 2a. That's your vertex formula. So that's where that comes from. Okay, and the other thing that we're going to take a look at in our first example for this section is what we call the discriminant, and this is where the discriminant comes from. Okay, there's your quadratic formula. Very useful formula. It helps you find roots. Your vertex formula is in it, right? The negative b over 2a, and it also includes the discriminant, which we will look at in example 1. In example 1, we're going to use a discriminant to determine the nature of the roots. And what we mean by nature of the roots is, when you solve your quadratic, is it going to have 2 roots, 1 root, or no roots? Okay, and our discriminant can tell us those things. So the discriminant is the expression b squared minus 4ac, which is located under the radical sign in the quadratic formula. So I pointed that out to you when we developed the formula. Use its value to determine the nature of the roots for a quadratic equation in the form of ax squared plus bx plus c equals 0. Okay, where a cannot equal 0. Okay, so what we mean by determining the nature of the roots is, does it have 2 roots, 1 root, or no roots? So you can determine the nature of the roots for a quadratic equation by the value of the discriminant. When the value of the discriminant is positive, in other words, when b squared minus 4ac is greater than 0, that's what greater than 0 means, positive, there are 2 distinct real roots. When the value of the discriminant is 0, in other words, b squared minus 4ac equals 0, there is 1 distinct root or 2 equal real roots. When the value of the discriminant is negative, okay, in other words, b squared minus 4ac is less than 0, so that means negative, there are no real roots. You can see that this is true by testing the 3 different types of values of the discriminant in the quadratic formula, and we're going to test it by graphing them. Okay, so if we have 2 roots, then we will get 2 x-intercepts. If we have 1 root, we will get 1 x-intercept, and if we have no roots, we will have no x-intercepts. So we're going to start with this first example. We're going to use the discriminant to determine the nature of the roots for each quadratic and then check by graphing. So our discriminant is b squared minus 4ac, and in this quadratic equation, a is negative 2, b is 3, and c is 8. So we're going to plug that into our discriminant. So we're going to go 3 squared minus 4 times negative 2 times c, which is 8, and we will get 9 plus 64, which gives us 73. Okay, so 73 is a positive number. In other words, b squared minus 4ac is greater than 0. Okay? And so, because it's greater than 0, okay, when the value of the discriminant is positive, there are 2 distinct real roots. So when they ask you to determine the nature of the roots, you say the discriminant is positive, or if you like, greater than 0. So there are 2 distinct real roots, okay, meaning 2 x-intercepts. So when I graph this on my graphing calculator, this is what I got. I got 1 root at negative 1.3. I got another root at 2.9. I got a y-intercept at 8. I found my vertex at 0.75. Okay, 0.75 and 9.13. And so I got this parabola. Okay, and as you can see, your parabola has 2 distinct real roots. Okay, so let's take a look at our next example. We first need to write this in the form of ax squared plus bx plus c equals 0. So that means I have to move my negative 9 over to the left, and it becomes positive. Okay, I can see that a is 3, b is negative 5, and c is 9. I'm going to plug that into my discriminant, b squared minus 4a squared, and so I'm going to get negative 5 squared minus 4 times 3 times 9, and so I can see that b squared minus 4ac is going to be 25 minus 108, and so b squared minus 4ac is equal to negative 83. Okay, and if you go back up to here, negative 83 is a negative number, so when we get a negative number, in other words, b squared minus 4ac is less than 0, we will have no real roots. Okay, so the discriminant is negative, or if you like, less than 0, so there are no real roots. So when I graph this, I found I had a y-intercept at 0 and 9 and a vertex around, I don't have the coordinates for it, but I know it's around here. And as you can see, because we have a parabola that is opening up and the vertex is above the x-axis, we have no x-intercepts, and therefore you can show by the graph that there are no real roots. Our last example, it's already written in standard form. You can see that a is a quarter. I'm going to use 0.25. b is -3, and c is 9. We will substitute those values into our discriminant, and we will get -3 squared minus 4 times 0.25 times 9, and so you get b squared minus 4ac equals 9 minus 9. And so b squared minus 4ac equals 0. Okay, so if we go back up here, when the value of the discriminant is 0, in other words, b squared minus 4ac equals 0, there is one distinct root, or if you like, two equal roots. Okay? So the discriminant is equal to 0. So there is one real root, or two equal roots. Okay, and I'll explain what that is in a minute. Okay, but right now I'm going to graph. So when I put this into my graphing calculator, I found that I had a y-intercept at 0 and 9. I had an x-intercept at 6 and 0, which I found was my vertex. Okay, and using the symmetry of the parabola, I also have another point over here, okay, because it will be the same distance that my y-intercept is from the axis of symmetry away, okay, to the right. And so I got this parabola. Okay, so as you can see, you have one real root, right? It's at 6 and 0. So what do we mean by two equal roots? Well, if I take this quadratic and I solve it, okay, by factoring, because I can factor this, I'm going to factor out the quarter. That leaves me with x squared minus 12x plus 36 in the bracket. And I can factor my trinomial, and I would get x and x, 6 and 6, provided they're both negative. So negative 6 times negative 6 is positive 36, and negative 6 plus negative 6 is negative 12. And so you can see that you have two equal roots, okay? And if I go to solve for x, okay, by setting both factors equal to 0, I get two equal roots, okay, both of them being at 6. Okay, so that ends our discussion on using the discriminant to determine the nature of the roots. So in this example, we're going to use our quadratic formula to solve quadratic equations. I've written the quadratic formula at the top of the page for easy reference. We're going to use the quadratic formula to solve each quadratic equation. We've got two. Express your answers as exact values, meaning that you should leave it as a fraction or in radical form. And so exact values in simplest form and to the nearest hundredth. Now you have to make sure that your quadratic equations are in standard form. So we will want to move the negative 4 over to the left so that we will get 9x squared plus 12x plus 4 equals 0. And because we're going to use this formula, we want to know what our values are for a, b, and c. So a is 9, okay, b is 12, and c is 4. And now we're going to plug that into our formula. We're solving for x, so x is equal to negative b, which is negative 12, plus and minus, and then inside the bracket b squared, so 12 squared, minus 4 times a, which is 9, times c, which is 4, all over 2 times a, which is 2 times 9. Okay, so we're going to start by simplifying what's inside the radical. And we will square our 12 and then minus 4 times 9 times 4. That gives us 0 all over 2 times 9, which is 18. Now notice your discriminant is b squared minus 4ac, which is in this case 12 squared minus 4 times 9 times 4. And look what we get. We get 0. What do we know about our roots when we have a discriminant of 0? Okay, well, we know that when our discriminant is 0, we're going to get one real root, or if you like, 2 equal roots. Okay? And so when we go to simplify this further, we're going to get x equals negative 12. And then, of course, the square root of 0 is 0, so you're just going to have negative 12 plus or minus 0. So that's just negative 12 over 18, which we will reduce to negative 2 over 3. So here is our exact value. Okay, if we work this out to the nearest hundredth, we get our calculator out. We're going negative 2 divided by 3, and we round off to negative 0.67. So this is nearest hundredth. Okay. So now let's take a look at our second example. It's already in standard form. We can see that a is 5, b is negative 7, and c is negative 1. We will plug that into our formula. So here's our formula. We're still solving for x. So x is equal to negative b, which is negative 7, so minus, and then negative 7, plus and minus the square root of, and then in brackets, negative 7 squared for b squared, minus 4 times a, which is 5, times c, which is negative 1, all over 2 times a, which is 2 times 5. Okay, so why specifically do you have to put that negative 7 in a bracket? Okay, well, because there's a difference between negative 7 in squared in bracket squared and negative 7 not in bracket squared. Okay, so when you square the whole negative 7 and you show that by putting it in brackets, that means negative 7 times negative 7, which is positive 49. If I don't put the negative 7 in a bracket, then all I'm squaring is the 7, not the negative. So I'm going to go negative and then 7 times 7, which is negative 49. So you can see there's a difference between putting a negative inside a bracket and outside of a bracket. Okay, so now we're going to simplify what's in the numerator, and at the same time, when I minus a negative number, I get a positive number, so minus negative 7 becomes positive 7. Simplify what's inside the radical, okay, and you should get 69 over, and then 2 times 5 is 10. Okay, so now take note, your discriminant, okay, is now 69, which is a positive number. All right, and when your discriminant is a positive number greater than 0, you know you're going to get 2 real distinct roots. Okay, and we will. All right, so this is our exact value. for our roots, right? 7 plus the square root of 69 over 10 and 7 minus the square root of 69 over 10. We're going to work it out to the nearest hundredths. So we're going to go 7 plus root 69 over 10, and we get 1.53. And then we are going to also work out 7 minus the square root of 69 over 10, and we get negative 0.13. Okay, so this is to the nearest hundredth. Okay, and we're going to verify one of our answers just to show that we can. I'm going to do it on the first one, so I'm going to verify this one. Now, my answer is that x is equal to negative 2 over 3. Remember, you always start with the original equation, okay? So my original equation is 9x squared plus 12x equals negative 4. So I want to plug in negative 2 over 3 into x squared. And I'm not going to use negative 0.67 because I want my work to be exact, okay? And so now when I square negative 2 over 3, I'm going to get 9 times 4 over 9. And then this is going to end up being minus, right? Because plus a negative number will mean minus. And I'm going to work this out. I can see that 3 goes into 3 once and into 12 4 times. So 4 times 2 is 8. So I get minus 8. And now I can reduce my 9s, and I get 4 minus 8 equals negative 4. And you can see that negative 4 equals negative 4. So you are correct. Okay, so this ends our discussion on using the quadratic formula for example 2. So in the next one, we're going to still use our quadratic formula to solve our quadratic equations. And we are going to express our answers to the nearest hundredth. But in these ones here, we have to do some simplifying first in order to get our equation into standard form. So on the first one, you will first start by distributing the 2m, and that's going to give you 2m squared minus 10m. And then you will move the 4 over to the left, and it becomes negative. So a is 2, b is negative 10, and c is negative 4. And this time we're solving for m, so I'm just going to write m equals on my quadratic formula. And I'm going to write it over here for reference again. Okay, so m equals negative b, so our b is negative again, so negative times negative 10 plus and minus inside the bracket. Make sure you put your negative 10 in a bracket before you square it. Minus 4 times a, which is 2, times c, which is negative 4, all over 2 times a, which is 2 times 2. Alright, so minus negative 10 is positive 10. Inside the bracket, in the radical sign, I get 132, and that's all divided by 4. Okay, so my discriminant is greater than 0. I have 2 real roots. One of them will be that m is equal to 10 plus the square root of 132 over 4. And when I work that out to the nearest hundredth, I get 5.37. And my second root is 10 minus the square root of 132 over 4. And I get that m is equal to negative 0.37. Okay, so your 2 roots to the nearest hundredth are 5.37 and negative 0.37. So on our next question, we will need to start by foiling. Okay, so we're going to FOIL what's on the left and FOIL what's on the right. So I'm going to go, and I'm just going to do this in my head. I'm not going to show all the steps. So when I FOIL what's on the left, I get 2x squared plus 13x plus 15, and that's equal to x squared minus 3x plus 2 on the right. So now I want to make everything equal to 0 because I want to put it in standard form. So I'm going to move everything over to the right, and so I'm going to get 2x squared minus x squared, which is x squared, 13x plus 3x, which is 16x, and 15 minus 2, which is 13. And now I can see that a is 1, b is 16, and c is 13. I'm going to plug all of that into my formula. I am solving for x, so I can write x equals negative b, so negative 16 plus n minus 16 squared minus 4 times a, which is 1, times c, which is 13, all over 2 times a, which is 2 times 1. So simplify what's in the radical, and you would get 204 all over 2. 204 is greater than 0, so I should get two distinct roots. Okay, 2 different roots. So x equals, so the first one is negative 16 plus the square root of 204 over 2. So x equals to the nearest hundredth negative 0.86. And my second root is negative 16 minus the square root of 204 over 2. And so I get x equals negative 15.14 to the nearest hundredth. So there are your roots for b. Okay, so this finishes our discussion on example 3. Okay, so in this next example, example 4, you are asked to determine the error or errors in the following solution. Explain how to correct the solution and solve the solution. So we're solving for negative 3x squared minus 7x plus 2 equals 0. Okay, so you need to know that a is negative 3, b is negative 7, and c is 2. So when we plug those into our quadratic formula, okay, which I will write here, okay, then you can see that we're going to plug negative 7 into negative b. So here's our first mistake, because this should read minus and then minus 7, okay? And inside the bracket, yeah, negative 7 squared, it is in brackets, so that's good. Minus 4 times a, which is negative 3, so that's correct, times 2, times c, which is 2, so that's correct, all over 2 times a, so 2 times negative 3. So on our first step, our error is, the error is that we didn't put a bracket around the negative 7 and put the 7 in front, because it's negative b, okay? All right, so that means that this is plus. Okay, and the second error in this one here shows up inside the square root bracket. When you times a negative, you're going to get a positive. So here's your second error. Okay, it should read plus. And so now when we get down to our line 3, okay, we already know this is plus. It's not 25 inside the bracket, right? Because it's 49 plus 24, which is 73. So this should read 73. And yeah, our denominator is good because 2 times negative 3 is negative 6. And so for line 4, what we should have is positive 7 plus and minus the square root of 73 over 6. Okay? So no, x is not 2 and x is not 1/3. All right, so how do we get them? We're going to go x equals 7 plus the square root of 73 over negative 6, and x is equal to 7 minus the square root of 73 over negative 6. And so on our first root, we will get negative 2.59 to the nearest hundredth, okay? And on the second one, we're going to get 0.26 to the nearest hundredth. Okay, so this concludes example 4. So in this last example, we're going to use the quadratic formula to solve an application problem. Leah wants to frame an oil original painted on canvas measuring 50 centimeters by 60 centimeters. Before framing, she places the painting on a rectangular mat so that a uniform strip of the mat shows on all sides of the painting. The area of the mat is twice the area of the painting. How wide is the strip of exposed mat showing on all sides of the painting to the nearest tenth of a centimeter? Okay, so first of all, the original width of your painting is 50 centimeters and the original length is 60 centimeters. You want to determine how wide the strip of exposed mat is, okay? We don't know what that is, but we do know that it's uniform all the way around. So we're going to let x be the width of the mat. Okay, so on your drawing, or on the picture, it would look like this. Okay, so there's x as a width, x, x, and x. Okay, so the next thing that we know from our information is that the area of the mat is twice the area of the painting. Okay, so I'm just going to draw some little pictures here. Okay, so this one here is going to be the painting. And the area for our painting is length times width, so in this case 50 by 60, so we get this area which is 3,000, okay? And in this case centimeters squared. Now the mat is bigger than the painting, okay? And we know that the area of the mat is twice the area of the painting, okay? So the area of our mat is twice the area of the painting. So twice 3,000, so we get 6,000 centimeters squared. Okay, so we're going to take all this information now and we're going to find out how wide this mat is all the way around your painting. Okay, so hopefully one thing that you have noticed is that we can come up with an expression which will give us the length of our painting as well, or sorry, of our mat, as well as the width of our mat, okay? Now, if you take a look at the length, we know that from here to here, between the blue lines, is 60 centimeters. We also know that, and I'll use red for this, we also know that from the painting to the mat is x, and we have that on both sides of our 60 centimeters. Okay, so if we want to come up with an expression for the new length, it's going to be 60 and then plus our two end pieces, right? So 60 plus 2x. We're going to use that same reasoning to work out the width, okay? So between our two blue lines, it's 50 centimeters. I know that between the painting and the end of the mat is x on both sides, okay? So I have that on this side also. I can use the same x, right? And so my new width will be 50 plus 2x. And because we're told something about the area, we're probably going to use an area formula, okay? All right, so let's write down what we know. We know that the width is 50 plus 2x. We know that the length is 60 plus 2x. And we know that the area of the mat is 6,000, okay? And we're working with a rectangle, so area formula for rectangle is length times width. So in place of area, or the A in the formula, I'm going to put 6,000 and times the length times the width. Okay, so here's my quadratic equation. I'm going to solve it. So the first thing that I want to do is expand. So I'm going to FOIL, okay, this expression. And when I do, 60 times 50 is 3,000. 60 times 2x is 120x. 2 times 50 is 100x. And 2x times 2x is 4x squared. And now I'm going to set everything equal to 0 because I want to use my quadratic formula to solve for x, and I need to make sure that my quadratic equation is in standard form. So I'm going to put my 4x squared term first, and then 120 plus 100 is 220x, and then minus, okay, because I'm going to bring this 6,000 over to the right, it becomes negative 3,000 minus 6,000 is negative 3,000. Okay, and I could use my quadratic formula from here. Okay, I'd be working with some large numbers, but I happen to notice that each of my terms is divisible by 4. And because I do have an equation, as long as I divide both sides by 4, my expression will still be equivalent. And so 4x squared divided by 4 is x squared. 220x divided by 4 is 55x. And 3,000 divided by 4 is 750, and I will plug these numbers into my quadratic formula. And my formula, I'm just going to write it here for you, is negative b plus or minus the square root of b squared minus 4ac over 2a. Okay, so according to my new equation, a is 1, b is 55, and c is negative 650. So I'm going to plug those in, solving for x. Negative b, so negative 55, b squared times 4 times a, which is 1, times c, which is 750, all over 2 times a, which is 2 times 1. Okay, so now simplify what's inside the radical sign, the square root sign, and you get 6,025 all over 2. And so you're going to get two x values. You're going to get one where x equals negative 55 plus the square root of 6025 over 2, and x equals the square root, 55 minus the square root of 6025 over 2. Okay, so when you get your calculators out, the first one will be about, because we're going to round off to the nearest tenth. Okay, and I'm going to get 11.3. And the second one, I'm going to get negative 66.3. I reject the second one because it's negative and I can't have a negative width or length. And so I can see that the mat has a width of 11.3 centimeters all the way around the painting. Okay, so the width of the mat is approximately 11.3 centimeters. And we have finished this section and we have finished this unit.